I'll also show you another way to do it, which is by comparing coefficients. So one other thing we can do, which is the same sort of idea, if we just look at what we had just a second ago, okay, when we got to this this starting line here at 6x minus 2, and what do we have? Ax plus 1 plus bx minus 3. We can compare coefficients. So what does that look like? Well, if we multiply out, this is one way you can do it, you don't have to do it this way, but if we multiply out, we can say a lots of x plus a plus b lots of x minus 3b is what we have on the right hand side. Okay. Over here there are 6 x's on the left hand side, and how many x's are there on the right hand side? Well, there's a over there, and then there's b more over there. So I can make an equation. I can say that 6, this is comparing coefficients, 6 is the number of x's on the left, and the number of x's on the left must be equal to the number of x's on the right. So how many are there on the right? Well, there's a lots, and then there's b more. And this is the first simultaneous equation. And then I can do the same for the number part as well. So let's do something like this. Let's change the pen. So I can say on the left there's minus 2 for the constant, okay, the number, and on the right hand side there's a over there and minus 3b. Okay, and if you solve these simultaneously and you can use your calculator, you should get the same results from before. So this is called comparing coefficients. It's often quite a quick way that you can do it. I thought we'd just have a look then at a harder one, which is the worked example. So more complicated quadratic, and this part time it's in 3 parts. But hopefully you're okay with me jumping right in and saying this statement here. Notice I'm not going to think about the denominator because I know that I would make those the same. So I'm going to jump in and say it has the x already, that will disappear. It will get the x minus 1, and it will also get the 2x plus 1 on the top. What will happen for the b? So try and see if you can follow the pattern. The b doesn't have the x, so it will get an x. The x minus 1, it will cancel out with the denominator. Okay, so or you can think of it, it was never even there. And then it's going to get the 2x plus 1 part as well. And then finally, the c is going to have, it's going to have an x, and it's going to have an x minus 1. Okay, and you can do the same thing as before. So you could substitute some numbers. So you could try this one, for example. If x equals 1, what would happen? Well, let's just look on the right hand side first. Can you see that a will disappear, c will disappear, but b will not disappear? What will you get for b? You'll get b times 1, so that's just b, and then this will be 2 times 1, so it's 2, so you're going to get 3b, so we're going to get 3b on the right hand side. What's it equal to on the left? Well, we just put it in over here. So 6 plus 5, so it's 11, minus 2, so it's 9. So quite quickly I can work out that b is equal to 3. What other numbers would I try? Well, 0. I could try x equals 0 to get my value for a. That will lead to a equals something. And then a bit more complex, but I could use x equals minus a half. Okay, and that will enable me to work out c. You can do these in any order. So having a go at doing it by, what are we doing here? By substituting values tactically, and that sort of works because actually it's an identity. So this relationship holds true. The left is equal to the right for any value of x. Or again, you could try this with simultaneous equations, but this is this would be satisfactory in terms of working out. You can jump to this line here and then showing your working to get these numbers. And that should take you up quite happily to do that last question.